I'm recording, so we're good to go. All right, so before we get into equations of circles, because that's what today is all about, this is also a great sort of insight to Algebra 2. You're going to have a whole conics section. Circles does fall under that. So before we can talk about anything to do with circles, we need to practice an old Algebra 1 concept, which is completing the square. So if you notice in the packet, I've written out for you all the steps to complete the square. But what I want to do is I want to now go through it with you to show you how to do it, refresh your memory, and hopefully it will all come back to you. So we only complete the square on quadratic equations. What do I mean when I say it has to be in a quadratic? When it's a quadratic, that means it's an x squared, then an x, and then a number that doesn't have a variable at all, a constant term. So x squared plus 6x minus 7, that is a quadratic. We're going to complete the square. So that means I'm going to make it something raised to the second power. That's what I mean when I say I complete the square. So your first step is you're going to take your equation and you want to keep everything that has a variable on one side, and any constant term or number that doesn't have a variable, you want to move it to the other side. So an x squared plus 6x, I want to keep on the left side. But that -7, it doesn't have a variable with it. So I want to move it to the other side. How do you think I'm going to move -7 to the other side? Exactly, we're going to add 7 to both sides. So now we are x squared plus 6x, I'm leaving some space there, equals 7. All right, your next step is you're going to go to the x term, not the x squared, the x term. What's the x term here? 6x. So you're going to go to the x term, and then you're going to look at its coefficient. Its coefficient is 6. You want to take that coefficient and take half of that coefficient. So it's essentially dividing by 2. Half of 6 is 3. That's not the number you want, though. So once you take half that coefficient, so half of 6 is 3, you're going to now take that quotient and square it. So 3 squared is 9. You're now going to take that product that you just got, that 9. I'm going to add it to the left side, but now to keep the equation balanced, I'm also going to add it to the right side. And by us doing that every single time, what we end up getting here, this trinomial x squared plus 6x plus 9, or whatever it will end up being, if you factor it, it will be something raised to the second power. What do I mean? If I go to factor x squared plus 6x plus 9, we need two numbers that multiply to +9 but add to a +6. Can somebody tell me what two numbers multiply to +9 but add to a +6? 3 and then another 3. So wouldn't this be factored x plus 3 and then another x plus 3? Or we can write it as x plus 3, the quantity, squared, equals 7 plus 9, which is 16. We have now just completed the square. We're going to practice this. It's just about memorizing the steps. Are we ready to do another one? Okay. It says independent, but I'm going to do it with you. What have I already done for you? I've already moved that 36 over. I've already moved the constant term over. Because remember, we want all the x's on one side, anything without a variable going to the other side. So here we're going to have x squared plus 16x, I'm leaving some space there, equals 36. So after you make sure your constant or your number without the variable is moved to the other side, you're going to go to your x coefficient. What is my x coefficient? What number? 16. Good. What are we going to do to that x coefficient? We're going to take 16 and do what to it? Take half of it, divide it by 2. Half of 16 is 8. Am I writing 8 on both sides? No. We're going to take that 8 and then do what to it? Square it. So what is 8 squared? 64. So I'm going to add 64 to the left side, and then to keep it balanced, what do I have to do? Add it to the other side also. Sam, you with me? Yeah. Okay. So now what is this going to be? Factored. X squared plus 16x plus 64 is going to be x plus 8, that quantity squared, equals 100. Let's do more practice. All right, number 2 here. Livy, what's my first step going to be? Excellent. We don't want the number without the variable on the same side, so we're going to subtract that 14. And when I subtract that 14, I end up with x squared plus 10x equals negative 21. Max, what do I do now?
You divide the 10 by 2.
Excellent. We're going to go to our x coefficient. We're going to divide it by 2. 10 divided by 2 is 5. So what should I do now with that 5? Square it. 5 squared is 25. I'm going to add that 25 to the left side, but I also have to add it to the other side to keep it balanced. Danya, what about x squared plus 10x plus 25? What do I do with that now? Yep, and what's that going to be? You got it. So this becomes x plus 5. We end up factoring that. Squared equals 4.
Is it always going to be like an x plus whatever squared, or can it be like not squared?
The whole point of this is to have it squared. So if it's not squared, that means we did something wrong. All right, number 3. We're doing number 3 together. So I've already moved the constant term over for you. So we're left with k squared minus 2k, leaving some space there, equals 3. We're going to go to our k coefficient, which is 2. Half of 2 is 1. 2 divided by 2 is 1, right? Half of 2 is 1. What's 1 squared? 1. That's okay. We're going to add 1 to the left side, and I'm also going to add 1 to the right side. But now be careful. When I come to factor my left side, what multiplies to positive 1 but adds to a negative 2? So we're multiplying to positive 1, but we're adding to negative 2. It can't be positive 1 and positive 1. Maya? Negative 1. So this ends up becoming k minus 1 squared equals 4. We getting the gist of this? You guys remembering? All right, I want you to do number 4 on your own. Who wants another minute? All right, let's go through this. So what should we have done first? Daniela, what did you do first? Excellent. We're going to bring that constant over to the other side. So we have w squared plus 2w equals 3. John, what did you do now?
Divide 2.
Good. Divide 2 by 2. That gives us 1. And then what do we do, Sam?
You put 1 there, so then it'll be w plus 1 squared.
Yeah, wait, first we got to add the 1 on both sides.
Yeah, then it'll be w plus 1 squared.
You got it. Then we factor and we get w plus 1 squared equals 4. How many people got that? Great. All right, moving on. All right, let's talk about the formula for circumference of a circle. We talked about that yesterday. There was 2 different formulas. We have c equals 2 pi r. What was the other one? So it's 2 pi r or, Mia?
C equals
Pi d. You got it. Where r is the radius and d is the diameter. All right, new formula for you, the distance formula. Actually, I think 3B we did the distance formula,
Yeah.
but just to refresh your memories on the distance formula. So this is not the distance the wheel turns. Remember what we did last class? This is different. This is distance between 2 points. So distance between 2 points is going to equal the square root of x2 minus x1 squared plus the quantity of y2 minus y1 squared. All right, let me refresh your memory on how this distance formula works. So we want to find the distance between the points 3, 1, and 8, 4. So I'm going to go ahead and I'm going to call 3, 1 x1, y1. And I'm going to call 8, 4 x2, y2. Because remember, every point has an x coordinate and a y one. So to find the distance between these 2 points, I'm going to use the formula d equals the root, the quantity of x2 minus x1 squared, plus the quantity of y2 minus y1 squared. And now I plug in. So I've assigned, so we want x2 minus x1. I've assigned 8 as x2. What did I assign as x1? 3. I assigned 8 as x2. I assigned 3 as x1. So in our first parenthesis, we're going to say 8 minus 3. Close that parenthesis and square it. Plus, now open my parenthesis. Now we need y2 minus y1. So look how I label things. I assigned 4 as y2. What did I assign as y1? 1. So now this is going to be 4, the quantity of 4 minus 1 squared. So now simplify inside your parentheses. So we end up with 5 squared plus the root of 5 squared plus 3 squared. Biggest mistake I see. So you see the square root and you see the squares. So you're like, okay, the 5 squared and the square root cancels out, so it's just 5. And the 3 squared and the square root cancels out, so it's just 3. So then I'm left with 5 plus 3, which is 8. That doesn't work because of what?
There's
The addition sign.
Yeah,
If it were all multiplication, it would work. If it were all just being multiplied, it would absolutely work. That addition sign changes everything. That addition sign is telling us, I want the square root of the sum, not just of each thing individually. So now I'm going to go ahead and I'm going to simplify under my radical. 5 squared is 25, 3 squared is 9, 25 plus 9 is 34. At this point in the year, I've already taught you how to simplify radicals. If you can simplify, you must simplify. But can we simplify the root of 34? 2 and 17, no pairs there. So our distance is just root 34 units long. All right, so now we're getting into equations of circles. Okay, I'm going to relate it to an equation of a line so it makes sense to you. Don't write this down because it really has nothing to do with the lesson. But we know the equation of a line in slope-intercept form is y equals mx plus b. That all looks familiar, right? We know whenever we see y equals mx plus b, that m represents the slope of the line, b represents the y-intercept of the line, and x and y, they represent all the points that exist on that line, the infinite amount of points that exist on that line. That gets represented by x and y. Okay, so before you went to Algebra 1 and you just saw y equals mx plus b, it meant nothing to you, right? It was just a bunch of variables. That's the same idea with the equation of a circle. There's an equation of a circle in standard form, and this equation, the variables represent different things. So the equation of our circle, or of any circle in standard form, is going to be, we should write this down, the quantity of x minus h squared plus the quantity of y minus k squared equals r squared. So as of right now, this means nothing to you. It's just a bunch of variables being put together that don't really have much meaning. I'm going to make it have meaning. Right? The first thing we need to know to have this have meaning is the center of the circle is going to be represented by h comma k. Or you know what, I'll write h comma k equals the center. So h comma k represents the center point. Okay. What do you think r represents?
Radius.
Good, Simon, radius. And last but not least, x comma y represents all points on the rim of the circle. So now I've gone through, now we know what every variable in this equation of a circle represents. Are we ready? Can I go to the next problem? Okay. So now I want us to find the equation of a circle whose center is 1, 5 and whose radius is 4. So when I say the equation of a circle, I mean an equation of a circle in standard form. So that's going to be x minus the quantity of x minus h squared plus the quantity of y minus k squared equals r squared. Okay, now remember, they're telling us here the center is 1, 5. So we know center is HK and the radius is R. So that means this center point is HK. What does that mean? H is what number? 1, and K is what number? 5. So now I'm going to go into my equation and put this in. So this is going to be x minus 1 squared plus y minus 5 squared equals, what did they say the radius was? 4. So equals 4 squared. So the only thing you have to expand upon here is the 4 squared. So this is going to be x minus 1 squared plus y minus 5 squared equals 16. How come I can't put in numbers for, or how come in this equation I don't have numbers in for x and y? Anybody know? How come I don't have numbers in for x and y? What do x and y represent? Mia?
Points on the rim that you were given.
Good, the point on the rim of the circle. Is there just one point on the rim of the circle? No, it's always changing. X and Y is always changing. That's why we don't have numbers in for X, Y. But the center of every circle, doesn't that stay the same? And the radius of every circle, doesn't that stay the same? Right, that's why X and Y are not filled in for, because they're always changing, depending on what point we're looking at. All right, something I want to point out to you. Do we all agree that my coordinates for the center are both positive? My x coordinate for the center is positive, my y coordinate for the center is positive. But in my equation, there's minus signs, right? So it's always the opposite. It's always the opposite sign of what's in your equation. So when it's x minus 1, that represents a positive 1. The y minus 5 represents a positive 5. It goes against what you think it would be, right? You think the minus, you see the minus, you think negative. It's not. It's the opposite sign of what's in here. So if it were going to be negative, what sign would be in there? A positive sign, an addition sign. And I'll show you right now. We're going to do independent number 1 together. It says find the equation of a circle with center 0, negative 2, and a radius of 3. So once again, I want the equation of a circle in standard form. So that's x minus h squared plus y minus k squared equals r squared. They're telling us the center is 0, negative 2. And remember, the center point is represented by h comma k. And they're telling us the radius is 3, which is r. Do we have enough information to plug in? Yes, absolutely. So now we're going to have x minus what number? 0, good. X minus 0 squared plus y minus what number? Negative 2. Good, Danya. It's not y minus 2. It's y minus negative 2, that quantity squared, equals the radius squared. Well, the radius is 3. Do you all now see this double negative? What happens when you have a double negative? What does it become? A positive. So now, in the first parenthesis, when I take nothing away from x, isn't it still x? So I can write this as x squared plus the quantity of y plus 2 squared equals 9. This is my equation of the circle. Again, if there's no number with the x, that number is 0. And if there's a plus sign in the parenthesis, that number is negative. All right, let's go on to example 2. Find the center and the radius of the graph. All right, well, this is x minus h squared plus y minus k squared equals r squared. We know center is h comma k, and the radius is r. Can somebody identify the center point for me on this graph? Only Danya knows, Vincent and Maya. Eloisa?
2, 7,
2 is good. The 7 should be what?
Oh, is it negative 7?
Good. It's 2 comma negative 7. Remember, the signs for our center point are always the opposite of what's in the parentheses. So since it's a -2, it's a +2. Since it's a +7, it's a -7. It's always the opposite of the sign in the parentheses. Who thinks they know the radius? So? Good. The radius squared is 64. So the radius is the square root of 64, which is 8. Perfect. All right, you all do independent number 2 right now on your own. Yes. All right, guys, let's go through this one. So somebody tell me, what was your center point? What did you identify as the center point? It is -5, 0. What about the radius? What did we identify as the radius? Maya? Good. Guys, the radius squared was 9/4. So you square root both sides. So that means the square root of 9 over the square root, I don't know what I wrote there. So that's the square root of 9 over the square root of 4, which ends up being 3/2. How many people got that correct? Good. All right, example 3, I'm changing this question. I want us to identify the center and radius. So right now, the way this equation is written, x squared minus 8x plus y squared minus 10y equals 8, it is not in the appropriate format that we would be able to identify anything. You cannot just assume that the radius is 8 because that's the number on the other side, and we don't know what the center is because it's just not in the equation of the circle format. So we need to put this into an equation of a circle format. How are we going to do that? You are going to make sure any number that doesn't have a variable is moved to the other side. Anything we need to do there? No. Then what you want to do is you want to group everything that has an x in one parenthesis and anything that has a y in another parenthesis. So I'm grouping together the x squared and the 8x. I'm leaving myself some space. Then a plus sign, and I'm opening up another parenthesis, and I'm going to group together the y squared and the negative 10y, leaving myself some space. And that's going to equal 8. For the x parenthesis and the y parenthesis, I'm going to complete the square. Right. Now we got to remember the beginning of the lesson. How do we complete the square? So somebody, Giselle, how about you? Can you complete the square for the x parenthesis for me? Good. Half of 8 is 4. And then what do we do? 4. Good. Now, once I add 16 to the left side, where else do I have to add 16? On the right side. Oscar, can you complete the square for the y parenthesis for me?
Plus 25.
You got it. Half of 10 is 5. 5 squared is 25. I add 25 to the left. I have to add 25 on the right. Michael, can you factor the two parentheses for me? Tell me what we end up getting. And then, okay, and that's going to equal 49. Now that we have it in this format, now can we identify the center and the radius? Absolutely. Adrian, what's the center?
4 and 5.
Good. Parenthesis 4 comma 5. Sam, what's the radius? You got it. 7. It's the opposite of what's in the parentheses. So it's x minus 4. It's always going to be the opposite sign of what's in the parentheses. So if it's a plus, then it's negative. If it's a minus, then it's positive. Okay, find the circumference of a circle represented by 3x squared plus 3y squared plus 6x minus 18y equals 15. Well, when they say find the circumference, that means they want c equals 2 pi r. In order to identify the circumference, we need the radius. Does anybody know anything I can do to this equation? 3x squared plus 3y squared plus 6x minus 18y equals 15 to make it simpler?
You have to group the ones that have X and the ones that have Y.
You're exactly right. But before we do that, we're going to group the x's, we're going to group the y's. Eloise is on the right track. Michael? Yeah, we can make these numbers a little bit simpler by dividing by 3. And then we're going to have x squared plus y squared plus 2x minus 6y equals 5. And now in order to identify the radius, I can't just say the radius is 5 or the radius squared is 5. I can't do that because what? This is not the equation of a circle, right? We have to fix this. We have to make it an equation of a circle, and we're going to do that exactly how Eloisa told us to. We're going to have x squared plus 2x grouped together, then put a plus sign, and we're going to have y squared minus 6y grouped together equals 5. All right, Jerry, complete the square for the x's for me.
X squared plus 2x plus 1 plus
Minus 9? What? I think I heard you. What'd you say? Y squared minus 6y plus what? 3 square 9 plus 9. And now I added a 1 and I added a 9 on the left side. What should I do to the right side? Add a 1 and add a 9. So now we factor. So we're x plus 1 squared and then y minus 3 squared equals 15. Is my radius 15? No, the radius squared is 15. So what's the radius? No decimals. That's dividing by 2. We're not dividing by 2. Guys, don't we just take the square root of both sides? Are there any pairs in 15? No pairs, so just root 15. So now that I know the radius, now I can find the circumference. C equals 2 pi r. So C will equal 2 pi root 15. That is our circumference. Leave the what? Leave the pi, yeah? Always leave the pi. Okay, I'm actually going to stop here. So then on tomorrow, right, you don't jump. So tomorrow I'm going to do example 5 and example 6, let you work on the independence, and then have you do your homework in class. So that's the plan for tomorrow.